problem 4.1.24. So the question is asking us to derive a OH fourth 5-point formula to approximate the function value, the derivative of the function f at a point x0 using these 5 points, or the values at these 5 points: x minus h, x0 minus h, x0, x0 plus h, x0 plus 2h, x0 plus 3h. Okay, so the idea here is similar as what we did in class. What we need to do is just to find some kind of a linear combination of these 5 values so that we can get some cancellations. We can take Taylor expansion of them, and by taking a linear combination of these Taylor expansions, we can do some cancellations. Eventually, we get a formula for f prime at x0. Okay, so what is the idea specifically? Now we first take the Taylor expansion of this f at x0 minus 1 at this point, at this value right here, and then we know the Taylor expansion is just giving us this. Remember that if you're going to derive a formula for f prime up to this order, then you need to take expansion up to the 4th order, and the last order also keep it as a residual term. Okay, so it has to be accurate up to the 4th order, and then you have this residual term. So we're going to do the same thing for all the others. So f0, x0, we don't need to take any expansion, you just equal to f0 itself. X0 plus h, and then we just take expansion. It's the same as this one here, except that h, negative h, it becomes h. Also here, it's just expansion at x0, but it's going to have the 2h. So everything you have here will be going to be 2h. Same thing, they're going to have 3h here. So now we have this 5. The purpose is to make a linear combination of them so that we can actually cancel out everything except for the f prime term. Okay, so we're not going to do that. So let's say that we're going to make a linear combination of these 5 terms. We're going to specify that this is going to be multiplied by 1. All the others are going to be multiplied by a, b, c, and d. This one is 1. Okay, and now by doing that, we will see that we're going to multiply the correspondingly. We're going to multiply a to this side, 1 to this side, b this side, c to this side, and d to this side. Remember, the goal is to cancel out everything except for this. Okay, we need to keep one of those. So for this term, if you want to get that, then you need to make sure that the coefficients, because we're going to multiply a here, b here is so a, b, c, d. Okay, so we need to make sure that eventually we're going to get 1. Keep 1 of this f prime. So that's the requirement for the f prime. F double prime, we need to cancel all the things right here. So you can see that all these are the same. The only difference is that we're going to have h squared here, 4h squared here, and 9h squared here. So that's why when we multiply them by a, b, c, and d, we need to make sure this is going to be 0. Okay, it's like you're multiplying this by a, this by b, this by c, this by d, but you need to have all of them equal, sum up to 0, so that the f double prime term can be cancelled out. Okay, same thing for the 3rd order term and the 4th order term. Okay, so now you have a system of 4 equations, and you have 4 unknowns, a, b, c, and d, and you can solve for them. And by solving them, you get these 4 values. So this is going to be the values you use. So by using these 4 values, and we're going to get this. So by using these 4 values applied to these 4 points, we're going to get this value plus this, plus a OH5 term, which is just a linear combination of these last terms, which is an OH5 term. So now we need to solve for this f prime. So solving for this f prime, we need to move everything to this side, also this to the other side, and divide both sides by h. So now after that, you will see you get this, and plus OH4, because this one divided by h is going to be OH4. So this is the formula for the f prime. We're using 5 points, and that's the steps we need to follow to figure out those coefficients.